Greetings for everyone. We are going to introduce you to financial analysis tools with MATLAB. I'm Ákos Koppánykis, working at the GAMEX Laboratory Solutions company, which is a partner company of MathWorks. MathWorks is the mother company of MATLAB products and MATLAB product family. We are responsible for giving technical support in this region. Personally, I'm working at the education department, and personally, I'm responsible for supporting teachers and researchers at universities, those teachers and researchers who are strong MATLAB users. Our main presenter will be Balázs Matolcsi, who is the financial expert in our team. And he will introduce himself soon. Before that, I'm going to tell you a few words about the possibilities with the MATLAB, how you can improve teaching and research with MATLAB and related tools. Okay, for example, there are such challenges in education in the research that you want to keep your students engaged and you want to teach interactively. So this is why online courses, live scripts, MATLAB Online, MATLAB Drive, also MATLAB Mobile is available. Also for professors, an automated assessment tool, MATLAB Grader, is available. Why and how you can start using MATLAB. Once you installed it, I recommend you to check out the online courses. So let's go and check out mathworks.com, click Academia, Learn. Online training. There are two kinds of trainings here available, those with the on-ramp word in their title. These are introductory short courses which can be completed within 2, maybe 3 hours. Very, very simple. And actually, as a best practice, we always recommend you to ask your students to complete, for example, at least the MATLAB on-ramp at the beginning of the semester. From the student side, it is actually very simple to check out what's going on. There is an option here, share progress with another user, for example, with your teacher. So they have nothing to do but type here the professor's email address, which belongs to his or her MathWorks account. And this way, the teachers can easily check the students' progress with the online courses. However, beyond the on-ramps, there are other, I would say, in-depth courses which take more time. You can learn about MATLAB, Simulink, yes, these graphical programming languages, also Simscape or stateful tools. Of course, you can learn about hot topics like machine learning, deep learning, and reinforcement learning. You can see that there are on-ramps as well as in-depth courses available. To those who are working or studying at the university with a campus-wide license, all these online courses are freely available. However, it is very important to mention that all the on-ramp courses are free for everyone without the need of having any license. Okay. Let's go back and let me emphasize that at that time I prepared these slides. I counted 13 courses which are on ramps, making more than 20 hours of content. However, I counted the same amount of courses uh, in-depth courses. However, these make more than 100 hours of content. So in my opinion, this is a great chance for everyone studying and learning at a university. Okay, I recommend you to use LiveScript and not only .m files with an old-fashioned way. Start use LiveScripts. LiveScripts are a great combined interactive document which combines text interaction, introduction, formatted text, maybe pictures as well as equations, also executable code with the output. Everything is within one document. Um, yeah, this is just something which makes your life easier. I will show you some examples with built-in applications which corresponds to the trend of development with low code. So again, this is something again which make your life easier. Whenever you are about trying out something, you don't have to dig into coding, but you can just open a built-in application with a user interface to your actual purposes. And well, after that, you can build a routine of it and generate code. But again, this is again something which make your life easier. Um, with the license of campus-wide license, you can use MATLAB Online. Let me show you how does it work again. When you check methods.com, click the matrix menu on the top right corner, click MATLAB, also open MATLAB. I'm sorry, it says it is already open in another window. Yes, and on the left-hand side, you can see your content of your MATLAB drive. Here in the between, I just opened up, yeah, live script with some control in the topic of derivatives. You can just, yeah, share content, share algorithms to play with them. There is also a dedicated um, tab for built-in applications. This is where you can find them. Yeah, and for example, these are the classification learner and deep network designer applications. What I'm going to show you at the end of this presentation. Just one thing before Balazs will get the stage. Always start with examples. So whenever you are about trying out something new, let's say again, methods.com. Okay, let's say you are looking for a new toolbox, deep learning toolbox, for example. There is a nice colorful page of that. However, just scroll down. You don't have to start with the documentation or the functions, but click on the examples button and you will have a lot of already working examples. You never have to start from zero. You don't have to reinvent the wheel. Just check out if there are a few, and well, actually there are hundreds of already working examples. Some other example, yeah, financial toolbox. Oh, wow. There is no what is happening here. Check out documentation, and yes, we have the examples related to the financial toolbox. Yeah, again, there are a lot of them already working. Whenever you are about trying out something new, please, yeah, just start with the examples, and you will get the capabilities. All right, Balázs, the stage is yours. How are you?
Thank you very much, Kopany, for joining me in. Hi, everyone. My name is Balázs Matolcsi, and I'm here on behalf of Gamalux Laboratory Solutions as well. I'm an application engineer there, and I'm the finance expert, as Kopany already mentioned. Okay, so in today's webinar, I'm going to lead you into the computational finance suite's elements in MATLAB. So I'm going to give a short introduction to it. And we are going to go through all the elements that are inside the computational finance suite, namely the data feed, database, and spreadsheet link toolboxes, which are useful for importing data into the MATLAB workspace. Then we are going to move on to the econometrics, financial, and financial instruments toolbox, which are used for specific financial tasks. Then we are going to go for risk management, which is a very important aspect of banking and loans and credit scoring and so on. So this is a very important toolbox inside MATLAB as well. Risk management is closely related to two other toolboxes, which are the statistics and machine learning toolbox, which contains some of the most basic descriptive statistic tools, and also some more sophisticated multidimensional tools like principal component analysis or dimensionality reduction and so on. And another closely related toolbox to risk management is the curve fitting toolbox, which is a built-in application into MATLAB, but it also contains some function that you can use for curve fitting task, regression analysis, and so on. Finally, the last two elements are also very important. The optimization and the parallel computing toolboxes are used for tuning models, the optimization toolbox, or solving linear or nonlinear programming problems. The parallel computing toolbox is able to exploit the energy and the power of multi-core processor units, CPUs, and also there are some functions in MATLAB which also support GPU calculation as well. And after this, I'm going to show you some use cases which are related to the academic world, the research world, and some use cases for the commercial sector as well. Finally, I'm going to talk a little bit about the function integration into MATLAB ops. So let's start with a theoretical excerpt from a conversation. So do we have the data to accomplish some kind of task? B answers, don't worry, we have the data somewhere. And there comes the question, on an internal server, in the cloud, or in the database? Yes. What do you mean? Some of them here, some of them there. Well, this is the point where MATLAB comes in with three great tools for importing your data from absolutely any source, which you can imagine. So the first toolbox, which is used for pulling in data into the MATLAB workspace, is called the data feed toolbox. The data feed toolbox enables you to access historical and real-time intraday market data streams from more than 10 supported data providers, including Bloomberg, FRED, Haver Analytics, and Quandl as well. You can build automated trading strategies based on the market events, and then you can also execute these trading actions through Bloomberg, EMSX, WinDataFeed, and also WinDataFeed's Xtrader or even the CQG. If you happen to have a database somewhere in your ecosystem, MATLAB offers a tool for this, which is called the database toolbox. It enables you to sophisticatedly interact with your relational and non-relational, or in other words, NoSQL databases. It, of course, has a native interface for SQL-based database systems like MySQL, PostgreSQL, and SQLite. And there is also a built-in application into MATLAB, which is called the Database Explorer, through which you can explore your data and generate some MATLAB code for your own custom database workflows if you wish. And one more thing to mention is that MATLAB Database Toolbox also supports Open Database and Java-based database drivers. So both of them, so Windows-based and cross-platform database drivers are also supported for database toolbox. The third tool is spreadsheet link, which is the direct integration of MATLAB functions into your already used Microsoft Excel spreadsheets. You can use all the capabilities of MATLAB inside a spreadsheet cell if you wish to. And a good thing to notice about the spreadsheet link is that it is supported by the latest versions of Microsoft Excel 2019 as well. So finally, we have our data in the MATLAB workspace, somehow from the data feed, from a database, or from an Excel spreadsheet. Now let's do some analysis. The first analysis tool we could use for macroeconomic and econometrics is the econometrics toolbox. It allows you to interactively analyze this time series data, which is available from all these sources that we talked about earlier. It has some built-in functions for visualizing and diagnosing your models that you select for analysis, like AR, ARIMA models, seasonal ARIMA models, and so on. With this toolbox, you can forecast and estimate the behavior of the economic systems with the Econometric Modeler app, which is also a built-in application into MATLAB. If you wish to take a look at the examples, I recommend it to you, just like Copain said previously, because it's a very good tool to quickly reach a goal with it. And of course, Econometrics Toolbox supports Garch and multivariate VAR models, or even Markov-based or time-varying Bayesian models for analyzing time series data. The second toolbox is, of course, Financial Toolbox, which mainly focuses on the mathematical modeling and statistical analysis of financial data. It includes backtesting of investment portfolios, optimization, estimation of risk, modeling credit scorecards with conditional value and value at risk, and so on. It also includes one of the most difficult questions and areas of research, which is option pricing. You can also evaluate your investment performance, and you can also conduct yield curve analysis if you wish to. The third tool should not be mixed up with the Financial Toolbox because it has a very similar name, but it deals with a different thing, because it's called Financial Instruments Toolbox. This toolbox provides functionality for pricing, hedging, modeling, and managing a large instrument portfolio. With this toolbox, you can conduct cash flow analysis, you can manage derivative instruments, packages based on interest rates or inflation, and so on. And also, you can solve pricing problems with respect to these instrument portfolios as well. But what about risk management and statistics? Well, neither is a problem, because first, MATLAB, as I previously mentioned in the agenda, offers risk management toolbox, which is great for consumer credit risk analysis, corporate credit risk modeling, and also market risk analysis with value at risk and expected shortfall inside it. There are also some lifetime models for probability of default, and there is also loss given default models built into the MATLAB workspace, and you can use it and tweak it to your own specific task. The second part is the statistics modeling and machine learning toolbox. This toolbox contains the most basic descriptive statistics tools, so means, covariances, standard deviation, and so on, visualizations, and clustering for some exploratory data analysis. It also offers the option to fit a distribution, a probability distribution to your data. You can conduct hypothesis tests, of course. It offers an option for regression analysis, classification, principal component analysis, and dimension reduction problems. And you can also use the built-in auto machine learning application for building a model based on your data inside MATLAB. And the third toolbox, we have this curve fitting toolbox. So these are the three that are closely related to risk management and statistics. This is an application built into MATLAB for fitting curves or surfaces to data that also integrates to the MATLAB core. You can also use the app without, you can use the curve fitting functions without the application, so you can implement it without the app, of course. There are several built-in linear and nonlinear test functions to calculate the best fit. You also get, of course, the goodness of fit values and so on for evaluating how good the curve fitting went. You can also create your own custom test functions or test equations in order to conduct the fitting process. Finally, there are two more toolboxes which are, I think, very important: the optimization and parallel computing toolboxes. The optimization toolbox contains several solvers for a wide range of optimization problems, such as linear or quadratic or nonlinear programming problems. It also offers a tool for multi-objective optimization analysis when there are many parameters and we have to tweak those parameters to reach the best result. It is also included in the optimization toolbox, as well as parallel computing toolbox, which is the last that I'm going to discuss with you in this part, which enables us to solve computationally complex data-intensive problems on multi-core processors. You can use the parallel for loops for conducting non-conflicting calculations or non-conflicting for loops, for example, and there are several numerical algorithms inside MATLAB that also support parallel computing on multi-core systems. Of course, there is an option inside MATLAB for example, graphical related calculations that support GPU execution, so you can harvest the power of your GPU, not just your CPU, of course. And the parallel computing toolbox also integrates with the financial tools. For example, if you wish to do cash flow analysis, for example, and you would like to do some multiple scenario calculations, and for example, random number generation with Monte Carlo algorithms, you can use multiple CPUs to conduct non-conflicting operations with the parallel computing toolbox. So I would like to switch my topic to use cases for academic users, as Koppány greatly introduced how useful MATLAB is for the academic students and teachers as well. I would like to highlight and point out that the teaching of finance by showing real-life examples and workflows is the future of teaching finance, in my opinion. Also, as MATLAB has many examples and built-in pre-built functions for lots of quite complex operations, it offers a way to quickly implement your solution or quickly implement your functions. It means that, for example, in research, you have more time for doing your research instead of reinventing the wheel again and having to do some complicated calculations and code that these are also available in MATLAB. Academic users have with well-documented and ready-to-use examples, as also Koppány said, for example, portfolio optimization approaches, efficient portfolios and frontiers, econometric modeling for macroeconomic studies, and also credit risk modeling, and so on. There are many examples. For commercial partners, computational finance suite also offers an alternative to legacy software solutions. There's a built-in way from the data feed toolbox to access and import any data from the largest providers such as Bloomberg and so on. You can analyze and fit models to time series data with econometrics toolbox. There is also a way to backtest and optimize investment portfolios and price instruments. You can analyze the cash flows or scenarios with derivatives, and you also have a way to price your solutions. For those working in the risk management area, you can model credit risk, market risk, and insurance risk. And I think the greatest power of MATLAB is that it has an up-to-date documentation with tested examples and tested code base for all the toolboxes, and of course the MATLAB core that you can use from time to time. Now I would like to show you some demo examples in the area of credit scorecard building and usage inside MATLAB and portfolio optimization in MATLAB. We are going to start by credit scorecard live script. Can I get a feedback from anyone if you're able to see my MATLAB window?
We see you, yeah.
Great.
Thank you.
Go on. Yeah.
Thank you very much. Okay, so this example will show you the workflow of calculating credit scorecard values used in, for example, consumer loan credibility. MATLAB has a built-in credit card data file that we can load with the load execution. Let's start with running the section. Let's load the credit card data. Here on the right-hand side, you can see that data is inside the workspace. This is a 1200 by 11 table. Let's open up this data table. Here you can see the columns: customer ID, customer age, time at current address, residential status, employment status, and so on. Customer income is here as well. And you can see that our response variable will be the status, which is the default status, so to say. Let's close it up. We are going to use the Binning Explorer first in order to clusterize the customers properly. So let's open up Binning Explorer. As you can see here in Binning Explorer, I'm going to import my data from the MATLAB workspace. So this is the Binning Explorer application, and now I've clicked this button here, Import Data, and this Import Data window is what I was talking about. Sorry for that. So here you can see the MATLAB variables, and also here the columns, which are inside the table. And this will be our response variable, which is the status. Here on the right-hand side, you can choose initial binning algorithm. We're going to choose monotone for first, which is the default value. So let's import the data. Okay, perfect. So here is Binning Explorer. On the left-hand side, you can see the predictor variables and their corresponding binnings. So time at current address, customer age, and so on. Binning Explorer enables you to, for example, split and combine bins with, for example, this split button here. Let's start by doing this just for a second. So we are splitting up this bin into two at the center point of 43, which is the customer age, of course. With the black line, black dotted line, you can see the weight of evidence value, which is, of course, our most important value here in binning. You can also see underneath here in this table the good and bad default values, odds, and weight of evidences, and of course the information value for this. For now, I'm going to leave this binning as it is, and I'm going to export it into the export it as a scorecard into my workspace. Let's name it my scorecard. Okay, and now I have created a scorecard object, which is inside my workspace now, as you can see here on the right-hand side. And I'm going to conduct some operations on this scorecard object. So there is several methods which you can call on a scorecard object, which include bin info, credit scorecard, fit model, plot bins, probability of default, validation of the model, and so on. So first, let's fit a model to the scorecard object to get the coefficients of the predictors for using the fit model function. So here you can see that the function will add all the predictor variables to the model. Also shows us the chi-square statistics and other p-values and so on. So now we have created a fitted model to our points. We are going to tweak our credit score points to set a target score to 500. The odds to 2, which is the target score at 500, is odds to 2. And I'm going to also set the points to double odds, so the PDO value, to 50. Okay, now I'm going to display the points for each predictor value. So as you can see here customer age, residential status, employment status, and so on. And each bin of, for example, the customer age contains a point value. So a customer with the age of between 33 and 37 will get a point of 54, for example. To sum up all these scores to the other predictor variables, we can use the score function, which is just a simple line of code here. And we can also calculate the probability of default and plot it as a histogram data here. So the probability of default for each of the customers. So there are 1,200 customers. Here are the probability of default values. Here are the, here is the histogram for it. And we can also export the CAP, ROC, and also the Kolmogorov-Smirnov plot in just a single line of code. That's what I'm going to show you right here. Let's run this section quickly. Here it is. We have the cumulative accuracy ratio profile here that you can see here. Here, MATLAB also prints out the accuracy ratios. It is 0.32 right now. We also have the receiver operating characteristics and the hour value. This is the area under this curve, of course, 0.66. And we also have the Kolmogorov-Smirnov plot, which has a maximum value, which is going to be the Kolmogorov-Smirnov statistics value, of course, at 0.23. You can also take a look at it in this table. So this is the KS statistic here. And you can see all the credit scores in a single table for each of the customers. Here is the probability of default, true bets, false bets, true goods and false goods, sensitivity factors, and so on. To sum up this first example, I would like to highlight that the number of codes line I wrote is just over 9. So under 10 lines of code, we have reached this result, and I think that's probably a very good result, so to say. So these built-in functions make your life much easier, in my opinion. The second example that I would like to show you deals with simple portfolio optimization. We are going to import some market data from the Dow Jones index, then create a portfolio from it. We are going to calculate the mean and covariances of each of the portfolio elements. We are going to set some investment constraints that we can set up in the portfolio object. And there we are going to run a portfolio optimization with the Sharps model. So there is a built-in data file which contains data from 2006 from the Dow Jones index. Let's run it and open it up, because this is the Dow Jones table. Here are the dates. Here are the Dow Jones index values, and these are the ticker names and, of course, the tick values for each of them that are contained in the Dow Jones index. I'm going to extract the tickers from the members. So these are the ticker names, AA, AIG, AXP, and so on. I'm going to convert the ticks to returns, of course, because that's what we use with the Sharps model. So these are the return values for each of the ticker names. I'm going to set up a portfolio from these values, so AA, AIG, AXP, and so on, all of them. I also set the risk-free rate for Sharps calculation to 1%, and I'm only considering 252 trading days in this calculation. So here you can see that MATLAB has created a portfolio object. Here is the risk-free rate. Of course, this is due to the fact that there are 252 trading days. Here is the asset list, the number of assets, and I could also set some other options if I wish to, but I'm not going to tweak these portfolio defaults for first. I'm going to estimate the means and the covariances of the assets that I included. So here you can see there are 30 asset means and 30 by 30 asset covariances. So this is a 30 by 30 covariance matrix based on these 30 ticker names that are inside our package. I'm going to just set the default constraints for the portfolio. For example, the weights of the elements inside the portfolio, of course, should not be negative, and their sum should be 1 as well. So I set up the constraints. Now I'm going to calculate the weights of the portfolio elements and estimate the maximum Sharps ratio and estimate the portfolio moments here. So these are the weights with which I should select my portfolio elements. I could scroll down a little bit more, but my best portfolio, so to say, will have a risk value of 0.0068 and the return value is 0.0015. We can also plot out the complete efficient portfolio frontier plot. It is also built into MATLAB, and I can take a look at my selected maximized best, so to say, portfolio on a single plot. Let's take a look at this. Here you can see that on the x-axis we have the risk, of course, on the y-axis the expected return, and this red star here on the efficient portfolio frontier, which is seen in blue. This red star here shows our best portfolio that we can reach. So to say, the highest expected return with the lowest available risk that we could combine from these portfolio elements, which you can see with these yellow dots here and the ticker names. Okay, let's move back to the presentation. These were the two examples that I wanted to show you. So I would like to summarize what you are getting with the computational finance suite if you opt for using it. So you can manage your financial data from any source, from the internet, from Bloomberg, from other providers, databases, or even Excel. You can also execute trading operations based on stream data from the largest providers that are present on the market. You can reach and manage your SQL and NoSQL-based databases with the database toolbox, of course. You can use spreadsheet link to call MATLAB functions from Microsoft Excel. You can also forecast economic trends by econometric modeling with the econometrics toolbox. You can analyze your investment performance or option pricing with the financial toolbox, of course. You can also model and manage your financial instrument portfolio if you have many financial instruments under your hand. With the financial instruments toolbox, you can also calculate consumer, corporate, or market risk with the risk management toolbox. And also you can use statistical tools for sophisticated data analytics. And on top of that, you can use your multi-core processors and even GPU to speed up your computation. And you get all this inside a single application, and this is MATLAB. However, there is one more thing that I would like to talk very, very quickly about before I hand the presentation over to Kopijn, which is the app designer that is built into MATLAB. You can create your own MATLAB application in less than an hour with App Designer. It offers a graphical user interface building application. So MATLAB has this built-in application with which you are able to customly use your own functions and build a graphical user interface based on your code. It offers hassle-free graphical user interface building with 50 plus built-in elements, buttons, sliders, radio buttons, and so on. And you can use callbacks to call all your functions in any of your toolboxes to interact with the graphical user interface. So you can seamlessly integrate any function of yours into the graphical user interface or your app. Moreover, you can also deploy and share your app with others as a MATLAB specific application, a standalone application which only requires a MATLAB compiler, so not the whole MATLAB package suite. Or you can even deploy your code to a web-based application as well, which is also a great thing to have. Thank you for the attention. Now I would like to hand over the presentation to Kopijn for a little machine learning and artificial intelligence things.
Balázs, thank you for the nice presentation. So let's jump into the techniques with artificial intelligence, because yeah, the hot topic, and AI is everywhere in these days. Yeah, artificial intelligence is something well, which refers to technique which enables you to mimic human way of learning and thinking, yeah, in a digital way. Yeah, right now I'm going to show you examples with classic machine learning algorithms as well as deep learning algorithms. As I mentioned, I'm going to show you the use of classification learner application and deep network designer applications, which are the part of the statistics and machine learning toolbox and deep learning toolbox. These are quite interactive application in order to speed up your work. However, you will see that at the end, you can generate code from that, what you did in the application. My example is about credit rating estimation based on different financial measures or financial ratios. The problem is the same, and I'm going to show you how you can handle this problem with the help of the classification learner and deep network designer. Let me emphasize again that you can learn details with the help of online courses. Um, Let me emphasize the fact that actually MATLAB is a very powerful tool for visualization and the analysis. This is why I'm going to show you, for example, confusion charts. Again, at the end, as Balázs mentioned, you can build application, and now MATLAB is capable to interact with other languages. Okay, so let's jump in the middle, and yeah, this is again a live script about the classification with machine learning. Our input data is like a big table. Each row represents data about a given company. The first column is the ID of that actual company. Then comes some financial measures like working capital, earnings before taxes, etc., etc. And at the end, you can see the credit rating, which goes from A to triple A or B to triple B or triple C. So there are actually 7 classes at the end. All right. We have the input data here, which is data of that kind of columns, and I just opened the classification learner application from the from here. Let's click on starting a new session and select our variable. The classification will be based on this table, which is already in the workspace. Response variable is recognized as the rating itself. The predictors are the other columns except the one with the IDs. So we uncheck the ID column and we can start the session. Each spot in the graph represents one line in the table, and you can really select which data do you want to represent against or as a function of which data. And up here, there are multiple algorithms to use. So first, a tree-based algorithm is already selected. I can select a nearest neighbor classifier too. Let's see, a medium, a KNN. However, actually, by one click, you can select them all and let the software use all of these algorithms. And at the end of the training, you can check which model, which algorithm fits the best to your data. Right now, let's use these two and click train all. And within a couple of seconds, the training is finished, and we can see then this in this particular case, the tree-based algorithm worked better because here we reached an accuracy of 70%. And right now, let me export this model under the name of trained model. I can close. this one right now. And okay, right now I can use this model to predict to do classification and prediction on new data. How? Let me open up this model structure, and actually it has a how to predict field, so you don't even have to remember how does it work. You can just need to open it and read it. So either you use the function handle within the structure, or just need to call the predict function with the model tree and the new data. And you can see on the output that the prediction is done. Let's do the same thing with the help of AI. So you will get just a picture. How does it look like in MATLAB? So let's imagine that you read a scientific paper that somebody at the other corner of the world did some analysis with the help of self-developed neural network. So why wouldn't you try it by yourself? So again, how does it look like? You open up the same input data. You split the data into training, validation, and test subsets. And okay, let's see. This very simple network architecture is described in that scientific paper. So let's open up the Deep Network Designer. It will also take a couple of seconds to load. And let me quickly reproduce with the help of this graphical interface. We are starting with a new network. However, there are available uh, pre-trained quite complex networks such as QuizNet or GoogleNet, which can be used, for example, for um, further adjustments. So not starting from zero, but for transfer learning algorithms. All right, but right now we are starting with a blank network. I just mentioned that I need a feature input layer. I mentioned that we are having these data, so we need 7 features. Then we will have fully connected layers, let's say a size of 20, then activation rectifying unit layer, and other fully connected layer. This one will be the last one, so here the output size has to be matched, has to match the number of classes, which is 7, as I mentioned, A to triple E, B to triple B, and triple C. And then I need a softmax layer to represent probabilities and a classification layer, because we have classes at the end. I make the connections in between them. I can just click auto range to look it well at a nicer look. I can analyze it if it has something wrong, but there is no warning or errors. So I can just export, let's say, generate code, and we will see that this code is representing the actual network architecture. Let me copy here, and yep, I have already did the training options. All right, and when I click run, it will also call the train network command on the on our table data, and at the end we will get a confusion chart which will represent the accuracy of our training. Okay, so let's click run. Okay, what is happening here? Okay, I'm sorry. I forget to switch to the right folder. I apologize. Let's run it again. Oh, yes. Yeah. Feature. Sorry, the number. The feature input layer was parameterized wrong. I'm sorry.
That was due to the ID, I guess.
Yes. And yeah, it starts learning. The accuracy is increasing. The loss is decreasing. And yeah, similarly to the previous result, we reached a validation accuracy just above somewhere 70%. And we see a confusion chart accordingly. We can see that, for example, yeah, most of the BB classes are predicted as BB. However, there is a chance when a neighboring class is the result. However, not a very bad classification within 20 seconds. However, you can see that can improve this. And the main message here that with the help of this built-in application, you can try out something. You can get to somewhere which is working within just a few hours. Thank you for the attention right now. In case of any questions, please don't hesitate to ask, and you can reach us out later as well. Thank you very much.